We're solving problem 15 from the AMC 12B from 2022. One of the following numbers is not divisible by any prime less than 10. Which is it? And then we are given all these answer choices. So all of these numbers have a power of 2, and an easy way to kick it out is just to see the pattern of the powers of 2. There's 2 to the power of 1 is 2. 2 squared, digit ends in 4. 2 cubed, digit ends in 8. 2 to the 4th power ends in 6. And 2 to the 5th power ends in 2. So we have this cycle of 1 to 4. So we know that so any power to the 6th, like 606 and stuff like that, will have a digit of 4. And since the divisibility rule is that the last digit has to be divisible by 5, which is literally just 5 or 0, we can kick B out since this digit 4 plus 1 equals 5. Okay? Now, so what we can do now is, well, let's see here. 2 to the power of 607 plus 1. Or it would be easier to kick out E at this point. We know that the units digit of a 7th number is going to be 1, 2, 3, 4, 5, 6, 7, ends in 8. So now we want to find the pattern for 3 in this specific answer choice. 3 to the power of 1 is 3. 3 squared ends in 9. 3 cubed ends in 7. 3 to the power of 4 ends in 1. And then it starts all over again. Wow, lucky us. It's the same pattern as always. So if this number ends in 8 and then 7, when you add those up, 8 plus 7 is 5. So we can kick E out. So now we're left with A, C, and D. Well, let's talk about D. Well, D is 2 to the power of 607 plus 1, which is, it ends in 9, okay? Let's see here. How else can we do this? If we have these values left, and it's divisible by 9, well, if there's a number 9 in it, it's possibly going to be divisible by 3, so we can already basically check that off. If it does not end in 9, well, yeah, sometimes it can be divisible by 3. Okay, but this is a bit harder to check now, except for, let's see here. If we have 2 to the power of 606 minus 1, this is going to be, it ends in 3, and this one also ends in 7. Now, this is going to be a hard choice for us to make here, but let's see. If we have, like, a very big number, like power of 2, like, it's going to be a multiple of 2, and then say it's 2. You add the last digit, in this case 606 is 4. 2 plus 3, this whole thing is going to be 5. Or if you keep on adding, say, random digits of 2 or just any random number, well, the thing is, you want a rule or something concrete we can lead on, but this seems like we're almost stuck at this point. We might actually be stuck here. So let's just consider our options. We found a pattern for the 2's. It cycles every 4. And we know that the prime numbers, the first 10 prime numbers, so there's, at less than 10, there's 2, 3, 5, 7, and that's it. So 5, we ruled out that these cannot be divisible by 5. 3, the sum has to be 3. Well, 2, it ends in 2. It cannot be. So our basic verdict is whether it's divisible by 3 or 7. Now, 2 of these answer choices have to be divisible by 3 or 7 to not work in this case. Now, so what can we do here? Well, we know that 7 squared is going to be 49. So my reasoning is that if this ends in a 9 and it's going to be a square, most likely a power of 2, is going to be divisible by 7. And so in this case, D is out. So now let's look at A and C. Let's take a look at A real quick. This is 2 to the power of 606 minus 1. That's 4. Minus 1 is 3. So whatever power of 2, it's 2 to the power of 606. So yeah, 2 times 600. A lot of times, if you just keep on adding, say 2 plus 3, 2 to the power of 1, this is 5. If you add 2 squared plus 3, this is going to yield 7. 2 cubed plus 3, that's 9 plus 3. So 9 plus 3 is 12. And we know that 606 can be divided by 3. And since 12's digits added up is 3, and that is divisible by 3, we know that A is out, so our answer has to be C.